In this video, we look at most asked Terraform interview questions along with answers and also learning resources to help you out. Alright, so I'm here on my computer screen and I have all these different Terraform interview questions along with answers and also learning materials to help you understand each topic properly. Now in this document, I have mostly real-time scenario-based Terraform interview questions, but I've also included some advanced Terraform interview questions like CICD with Terraform, automated testing in Terraform, upgrading Terraform version, and lot more. So make sure you watch this video till the end. And if you want me to share this document with you, comment down Terraform interview questions and answers, and I will share this document as a PDF on LinkedIn and also share the link of this document in the video description. Now with that being said, let's get started with this Terraform interview questions and answers video. Let's go. So whenever you sit for a Terraform interview, the first typical question that you will get is going to be, what is Terraform and how it works? So we all know Terraform is an infrastructure as code tool that lets you write the code for the infrastructure that you want to create in the cloud. When you write the code, you then run the Terraform commands and Terraform will create this infrastructure in the cloud. Terraform does this using the state file. So a state file in Terraform is a file that will store the data of all the infrastructure managed through Terraform. And Terraform uses the state file to compare with the actual infrastructure on the cloud to tell us what is going to be created or deleted according to the configuration you have in these files. So this is how Terraform works. And if you look at the answer here, Terraform is an IAC tool that lets you write code to define and manage your infrastructure. You describe your desired infrastructure in the configuration files, which are these files here, the .tf files. And then Terraform figures out what needs to be done to achieve that state and then make it happen by interacting with cloud providers or other infrastructure platform. Here is the workflow. You first write the code, you then plan to check what is going to be created or deleted, and then you apply it to have that infrastructure on the cloud. So this is how Terraform works. Moving on, the next question is a scenario based question where it says a DevOps engineer manually created infrastructure on AWS, and now there is a requirement to use Terraform to manage it. How would you import these resources in the Terraform code? Okay, so according to this question, the engineer has created some infrastructure on AWS manually, and now they want this infrastructure to be managed through Terraform. So how can you do that? So let's consider this is an infrastructure or an EC2 instance created manually through AWS console, and now you want this to be managed through Terraform. So for an infrastructure to be managed through Terraform, it has to be present inside the state file, which is this state file here. So we will start with creating the configuration first. We will create the code, which is going to be a resource block for this particular instance, specifying the instance type, specifying the AMI used and all the other things. Once you write the code, for this to be inside the state file, we will run the Terraform import command. So if you look at the answer here, we first write the Terraform configuration for the resources that we want to be managed through Terraform. Once we write the code, then we run the Terraform import command, and here is the command here. So Terraform import with the resource type and the unique ID. So we run Terraform import command for each resource, specifying the resource type and its unique identifier. Once we follow these two steps, then the infrastructure will be managed through Terraform and not manually. So we have to repeat these steps or repeat this process for each resource that we want to manage through Terraform. Now if you want to learn more about how Terraform import works, here is a great blog by Terraform itself where they will tell you how you can use Terraform import command to manage infrastructure through Terraform rather than manually. Moving on, the next scenario based question is, you have multiple environments, dev, stage, prod for your application, and you want to use the same code for all these environments. How can you do that? So according to the question, there are different environments for an application and you want to use the same Terraform code for all these different environments. How can you do that? To achieve this, we have actually two different approaches. The first is using Terraform modules and the second is using Terraform workspaces. So what is Terraform module? A Terraform module is a block of code or a code template for infrastructure components, and you define them once and then you can use them with different configurations for various environments by passing in different parameters or different variables. So this is the first approach where you can use the same code for different environments. The second one is using Terraform workspaces. Using workspaces, you will have different state files for different environments using the same code. So Terraform workspace provides a way to manage separate states for same set of configuration file. Each workspace maintains its own state file, allowing you to work on different environments concurrently without interfering with each other. Here is a great blog that will help you understand how you can use the same code with different multiple environments using the Terraform module approach and also using the Terraform workspace approach. I recommend you checking this out if you want to learn more about how you can use the same code with different environments. Moving on, the next question is, what is Terraform state file and why it is important? So we already know state file is something that is going to have information about the resources managed through Terraform, and this is usually a JSON file. So if you look here, Terraform state file is a JSON or a binary file that stores the current state of the managed infrastructure. State file is like a blueprint that stores information about the infrastructure you manage, and it is crucial because it helps Terraform understand what's already set up, what changes need to be made. By comparing the desired state with the current one in the state file, Terraform can make accurate updates to your infrastructure. So this means Terraform state file is very important for Terraform to work, because using state file, Terraform actually compares the configuration with what you have on the cloud, and then it will actually create or delete stuff. So Terraform state file is a JSON file which is very important for Terraform to work. So next question is a scenario based question. A junior DevOps engineer accidentally deleted a state file. What steps should we take to resolve this? So we already know state file is very, very important. And in this question, a junior DevOps engineer has accidentally deleted a state file. What steps should we take to recreate it or resolve this? So as we know, state file is important. It is always recommended to take backups. So the first step is going to recover backup. If there is a backup available, try to restore the state file from the backup. If there is no backup, then you need to manually create state file, which is very time consuming, and you can do this by using Terraform import command. So you will check what resources are there on the cloud, and using Terraform import command, you will import every single resource and put them into the state file to recreate the state file. Here is another great blog where the author accidentally deleted the state file, and then using Terraform import command, they recreated the state file. So here is the Terraform import command and how they use Terraform import to recreate state file. So make sure you always take backups. If there are no backups, you will have to recreate it manually using Terraform import command, checking each resource on the cloud. Once you do that, make sure to review and monitor if everything is working fine. If you get this question in the interview, the follow-up question would be, what are some best practices to manage Terraform state file? So as we know, Terraform state file is important, and I've been continuously saying this. Here are some best practices to make sure that you properly manage your state file. The first best practice is to use remote storage. So rather than storing your state file locally in your local machine like this, you can store your state file on remote backends like S3, Azure Blob Storage, Consul, and lot more. So you should always store the state file remotely for safety, collaboration, and version control. Second is state locking. When you store your state files on remote backends, you will obviously have collaboration, which means multiple people will constantly update the state file by running different Terraform commands. So you need to enable state locking to make sure there are no conflicts whenever multiple people are changing the state file. So state locking will prevent conflicts in concurrent operations. Next is to access control. Make sure only authorized people or services have access to the state file to avoid deletion or corruption of the state file. Next is automated backups. Make sure to set up automated backups to prevent data loss for the state file. And lastly, environment separation. Maintain separate state files for each environment, or utilize Terraform Workspace to manage multiple state files. So here are some different best practices to manage Terraform state file. Let's move on. The next question is, your team is adopting a multi-cloud strategy and you need to manage resources on both AWS and Azure using Terraform. So how do you structure your Terraform code to handle this? So according to the question, your team is adopting multi-cloud strategy where you want to create code on AWS as well as on Azure. So how can you do that? So we already know Terraform is a cloud agnostic, which means Terraform can work on different clouds at once. So you can also create resources on AWS, also on Azure, also on GCP. So you will do that by first defining the providers. If you want to create resources in AWS, you will have to define AWS as a provider. In this case, we are creating resources in AWS and Azure. So we will define provider for AWS and Azure as well. Once you define the provider, you will then start with writing the code for the resources you want to create in AWS and Azure. So here are two steps. First, you define the provider, then you write the code for different resources you want to create. Moving on, the next scenario-based question is, there are some bash scripts that you want to run after creating your resources with Terraform. How would you achieve this? So you have some bash scripts that you want to run after the resources are created. You can do this using provisioners in Terraform. So there are three different types of provisioners in Terraform. There is file provisioner, local exec provisioner and remote exec provisioner. For us to run bash scripts, we can use local exec provisioner and remote exec provisioner. The difference between these two are local exec provisioners are used to run commands in your local machine. Remote exec provisioners are used to run commands or run scripts inside your remote machines. So here is a simple example. We are using a provisioner which is a remote exec provisioner, and we are running some commands here. The first command is to give permissions for the script that you want to run, and the second command is to actually run the script. When you use remote or file provisioner, you also need to define the connection block, which is how you will connect to the remote machine where you want to run your scripts. So you can see the explanation here. In this configuration, we are using a remote exec provisioner which executes a bash command on a remote machine via SSH. You need to provide the necessary connection details such as SSH user, private key, and the host. So this is how you can run bash scripts using remote exec provisioner if you want to run it on remote machine. If you want to run it locally, you can use local exec provisioner as well. Moving on, the next question is, your company is looking ways to enable high availability. How can you perform blue-green deployments using Terraform? This is a very nice question, and I have got this question a lot of times when sitting for interviews. So what is blue-green deployment? A blue-green deployment is a strategy where you have two identical environments, a blue one and a green one, like this. According to the question is asking, how can you use Terraform to set up a blue-green environment? So you can use Terraform, you can obviously use Terraform to do this. So Terraform facilitates this by defining two sets of infrastructure resources with slight variation. So maybe you can have two different auto-scaling groups or two different Azure virtual machine scale sets. What you can do is you can create a new environment alongside with the existing one, which is going to be the green one. And you will test if everything is working in the new environment. If everything works properly, you can then switch the traffic either using load balancers or using DNS records. So you can see you first create the new environment alongside with the existing one. You validate if everything is working fine in the green environment, and if it is working fine, you can then use application load balancer or DNS records to switch traffic between these two. Again, to understand this more clearly, I also have another blog or documentation by Terraform itself, and they have defined how you can use Terraform for blue-green deployment or for canary and rolling deployment as well. So go through this to understand more on how you can use Terraform to set this up. Moving on, the next question is, your company wants to automate Terraform through CICD pipelines. How can you integrate Terraform with CICD pipelines? This is again very, very important because every company is using CICD pipelines to automate the Terraform infrastructure provisioning. So make sure you go through this answer very properly. I have also explained this very thoroughly in this particular video where we have used GitLab CICD to automate Terraform resource creation and deletion. So inside this video, we have created a CICD pipeline using GitLab. In this CICD pipeline, we have different stages for init, for plan, apply, and destroy. So similarly, for you to set up or automate your Terraform through CICD pipeline, you need to first push the Terraform code, this code onto a remote repository like GitHub or GitLab, wherever you want to set up a CICD pipeline. Once you have your code there, you can then start with writing the CICD script, which will have different stages for init, for validate, for plan, for apply. For apply, you can either do it manually, where you will create merge request every time there's a change in the Terraform code, and once it is approved, only then resource should be created. Also, you can set up approval for deletion as well. So here are the different steps. You first commit the code to version control system, set up a CI/CD pipeline that will check every time you make a change inside your Terraform code and you push it to this repository. The CI/CD pipeline will run. In the pipeline, you can execute Terraform commands such as init, validate, and plan to ensure the configurations are valid and generate an execution plan. You can do this by defining different stages in the pipeline. Use Terraform apply command to create or modify infrastructure based on approved changes. So whenever you make a change, you can then create a merge request. When this merge request is accepted, only then the apply stage should be done. Optionally, you can also use testing and verification tool to validate and deploy infrastructure. So you can include different frameworks or different tools to include testing or to make sure your Terraform syntax is correct. Finally, trigger additional pipeline stages for application deployment and testing and release. Optionally, you can also have other CI/CD pipelines where you can also add other CI/CD pipelines for application deployment, testing, and release. So this is how you can integrate CI/CD pipelines with Terraform. I highly recommend you checking out this video where I've explained step by step on how you can use CI/CD with Terraform to automate deployment on the cloud. Moving on, the next question is, describe how you can use Terraform with infrastructure deployment tools like Ansible or Chef. So in this question, it is asking how you can use Terraform with configuration management tools like Ansible or Chef. So we all know Terraform is an infrastructure provisioning tool which is used to create infrastructure, whereas Ansible or Chef are configuration management tools which are used to configure stuff. So using Terraform, you can create EC2 instances, but using Ansible, you can install something on it. So Terraform can be used in conjunction with infrastructure deployment tools like Ansible or Chef to manage infrastructure provisioning and configuration. Ansible and Chef can handle tasks such as installing a software, configuring servers, managing services, while Terraform focuses on infrastructure provisioning and orchestration. So it is a very good practice to use these two tools together to create or achieve a comprehensive infrastructure automation solution. Now, if you have confusion between what is Terraform and what is Ansible and how they are different, you can check out this video where I've explained how Terraform and Ansible are different from each other and what do they actually do. So you can use Terraform with Ansible, and that we have answered here. Moving on, the next question is, your infrastructure contains database passwords and other sensitive information. How can you manage secrets and sensitive data in Terraform? This is a very, very important question. Companies are very concerned about how you manage secrets when working with Terraform. So you need to know how to manage secrets like database passwords, credentials when working with Terraform. Here are some best practices that you can follow to manage secrets when working in Terraform. The first best practice is never hard code secrets in your Terraform code. Never put your database passwords, never put your credentials inside Terraform code, because anyone will be able to see it. Even if you push it on repositories, everyone will be able to see it. So never hard code it in your code. You can store secrets outside version control files. Never push them on GitHub as well. And you can, rather than storing it inside the code, you can use tools like HashiCorp Vault or also cloud specific secret management services like Secrets Manager in AWS. Also, you can also use Terraform input variables or environment variables where you can pass this information while you run the commands rather than storing them in the code. So here are a few different best practices that you can use to make sure that you can protect sensitive information and minimize the risk of exposing secrets intentionally or unintentionally. So moving on, the next question is, you have RDS database and EC2 instance created using Terraform. EC2 instance should be created before RDS. How can you specify dependencies between two resources? So you have RDS database and you also have EC2 instances. You want this EC2 instance to be created before the RDS is created. So to do that, you can use a meta argument, which is a depends on meta arguments. Using this depends on meta argument, you can define that the EC2 should be created first and then the RDS should be created. So in Terraform, you can specify dependencies between resources using depends on attribute within the resource block. And I have explained this again in this video where I've shown how you can use depends on argument to create resources first. So make sure to watch this video if you want to learn how you can use depends on meta argument to create resources before any other resource. Moving on, the next question is, you have 20 servers created through Terraform, but you want to delete one of them. Is it possible to destroy a single resource out of multiple resources using Terraform? So this is again a very tricky question. Whenever you want to delete stuff through Terraform, you will run the Terraform destroy command. But when you run Terraform destroy command, everything that is defined inside your configuration will be deleted. So let's say you have 20 servers, how can you delete one of them? So if you want to delete just one of the resources defined among the 20 resources in the Terraform, you can use Terraform destroy command with a target attribute here. So it is possible we can use Terraform destroy target command followed by the resource type and the name to destroy a specific resource. So you can use target with the instance that you want to create, that you want to delete, and it will only delete the particular instance rather than deleting all the 20 servers. And again, there's a documentation by HashiCorp which will tell you how you can use Terraform destroy with a target attribute here. So make sure you go through this if you want to understand more on how you can destroy a particular resource rather than destroying everything. Now moving on, the next question is, what are advantages of using Terraform's count feature over resource duplication? So in this question, they're asking you, what is the advantage of using count instead of resource duplication? So a count feature or a count meta argument is used to define how many resources you want to create. For example, you can check here. Here is the code to create AWS instance. In this block of code, we are defining count as 4, which means it will create 4 instances of these configuration. Other way to do this is to rewrite the code 4 times. With this, I'm not writing this code 4 times. So this is the benefit. Using count, you can create as many resources as you want without actually writing the code. So using Terraform's count feature provides advantage over resource duplication by allowing you to dynamically create multiple instances of a resource based on given condition or a variable. With count, you can define a resource block with the count value that evaluates an expression such as variable or a conditional statement. This reduces code duplication and enable more efficient resource management and scalability. So it is always advised to use count rather than defining your code blocks multiple times. You can also add some advanced expressions to enhance your Terraform code. Here is the official documentation by Terraform on count meta argument. I also have a short video on how you can use count and count.index. So if you want, you can check it out. Moving on, the next question is, what is Terraform's module registry and how can you leverage it? This is again something that you need to know if you are working on Terraform. A module registry is a place where you can find different modules that you can use rather than writing the code yourself. So here is the module registry where you have different modules. There is a module for IAM, there is a module for VPC, for S3 bucket, for EKS, everything. So let's say you want to create EKS cluster. Rather than writing the code yourself, you can just go ahead and use this module. If you want to check the code for the module, you can also check the code here. This module is created by Anton and then the code is present here on the GitHub. So module registry is like a place where you can find all the different modules that you can reuse rather than writing the code yourself. So Terraform's module registry is a central repository for sharing and discovering Terraform modules. The module registry allows users to publish their modules which are reusable and shareable components of Terraform configuration. By leveraging the module registry, you can easily discover existing modules that address your infrastructure needs, reducing the duplication of effort, and you can reference modules in your Terraform code using their registry URL and version. For you to use any particular module, you can see a block here. Inside the module block, you can define a source as the module that you want to use. Now moving on, the next question is, how can you implement automated testing for Terraform code? This is again very important. Security is something that you need to put everywhere, even in your Terraform code. So how can you implement automated testing? By default, Terraform provides you with Terraform validate and Terraform format command, which will check the syntax and also format the code according to Terraform best practice. But along with this, you can also use other tools like TerraTest, TFlint. There's also Kitchen Terraform and a lot more. I have defined all the tools here. So for you to enable or implement automated testing, you can use all these different tools. So why do we use automated testing? We use automated testing to validate if the syntax is correct or if there are any infrastructure changes, to validate if the syntax is correct, to detect issues earlier, and also to ensure the desired state matches the actual state. This involves creating test fixtures, defining test scenarios, executing Terraform operations, and all this. So different tools that are used. For unit testing, you can use Terraform, Compliance or TerraTest. For integration testing, you can use TerraTest, Kitchen Terraform. For linting, you can use TFlint or Checkoff, and then other tools as well for static analysis, for mocking, for everything else. Here's another great blog on Medium for testing on Terraform. So you can go and check it out if you want to know how to enable automated testing. Moving on, the last question we have is, you are tasked with migrating your existing infrastructure from Terraform version 1.7 to version 1.8, which is the latest version as of now. So what kind of considerations would you take? So whenever you are tasked with migration, how would you do the migration from a particular version to another version? So whenever upgrading a Terraform version from a particular version to another version, the first step is to always review the upgrade guide. Whenever Terraform releases a new version, there is always going to be a documentation similar to this. So you can find how you can upgrade a Terraform to a particular version, which is version 1.18, the latest one as of now. So first step is to review upgrade guide to understand what changes are there, what has been deprecated, and then new features. Once you do that, you will then update your configuration files according to the changes or the new syntax, and to handle deprecated features as well. Ensure thorough testing, monitor after you make the change, monitor if everything is working fine. Always check on the non-prod environments before you shift to the prod environment. obviously, and then document any changes and also provide training to your team members. This is how you should be upgrading a Terraform version from one version to another. So in this video, we have now covered very important Terraform interview questions. I hope this video was informative. If you have any questions, any doubt, do let me know in the comment section. Also comment down if you want me to share this document with you. And also comment down what should we cover next. Should we cover Docker interview questions or Kubernetes interview question? Let me know in the comment section. Thank you and have a good day.